As I said at the end of the last presentation, this time we'll talk about some concepts with which a simple user can interact, someone who just wants to receive, send, or hold funds. To receive Bitcoin, we need a valid address, or we can have multiple addresses. How do we get a valid address? There is no central authority we need to talk to in order to give us access. Anyone can simply create addresses, and if they are created properly, they will be valid for the Bitcoin network. To create an address, first a private key needs to be created. Then, from the private key, a public address can be created. For this whole process of creating keys, a wallet can be used. Wallets are programs, applications, that create and manage private keys, keep track of the funds from the addresses they manage, can create and sign transactions. And they can be of several types. They can be mobile applications for Android, iOS, or desktop programs for Linux, Windows, Mac. They are applications that can create these private keys, and they have nice graphical interfaces through which we can do several things, such as create transactions or see how much funds we have. Or they can be hardware wallets, physical devices, which can look like memory sticks or like pocket calculators. They are relatively small devices. They can be connected to the mobile or desktop wallets, so we can have a nice graphical interface. And they create the private keys on the hardware device. And even if they are connected to another device, the private keys always remain on a secure area of the hardware wallet. And there can be types of wallets depending on how they create the private keys, if they create them randomly or if they create them from a single master key. A wallet does not contain Bitcoin. You can't have Bitcoin on your phone. You can't have Bitcoin on a stick. Bitcoin are only on the blockchain. What a stick or a wallet can have is that it will contain the private keys with which we can access the funds from the addresses created from those private keys. If we own the private keys, we have direct access to the funds from their addresses. There is this confusion, unfortunately, that you won't make, because now you know. It's this mistake in the terminology used. For example, I remember an episode of The Big Bang Theory, which you may know, in which they were looking for some Bitcoin that they got after the mining process a few years ago. And they thought those Bitcoin were on a laptop. Then they realized that those Bitcoin were on another laptop. And then they remembered that they actually downloaded the Bitcoin on a stick. I know that the episode completely misled me. This was before I actually knew how Bitcoin actually works. So, as long as the created private key is valid, and from it a valid address is created, it will be valid in the Bitcoin network as well. So, an interesting thing is that a private key can be created offline, or even by hand, because a private key is actually a very large number, between 1 and almost 2 to the power of 256, we need to create randomly a number of 256 bits, 32 bytes. So you could use a pair of dice that have 16 faces each, rolled 32 times. It's not indicated. It is best to use a wallet for this, because a wallet will be truly random and it will avoid most of the mistakes that a human could do in this whole process. The idea is that these private keys can be created offline, because they are not stored anywhere on the network. They are managed and stored by the wallet you want to use. And because we don't go to a central authority that assigns us private keys every time we want to create a new address, they could be created randomly by a wallet. And because the size of a private key is extremely large, about 10 to the power of 77, it is extremely unlikely that two keys will be identical. And a comparison often given is that the number of atoms in the universe is estimated to be 10 to the power of 80. This is to put things in perspective. So really, we can create new keys with their associated addresses without having any collisions. Now, modern wallets don't just create keys randomly, a seed will be used, that we'll talk about in a little while. In this way, anyone can participate. Anyone can create addresses where they can receive funds, regardless of the social status they have, regardless of the country in which they live. It doesn't matter how old they are, it doesn't even matter if they are a person or a machine. Anyone can create valid addresses with their private keys and can participate in this financial system. The process for creating addresses looks like this. From the private key, a public key will be created. It is a one-way process, so there's no way to get from the public key to the private key. And then the public key will be passed through two hashing algorithms to produce the address. Again, this is a one-way process, so from the address it's not possible to get back to the public key or the private key. So, to access the funds from a certain address, asymmetric cryptography is used. In short, this idea of public key cryptography works like this. The private key is used to sign a transaction by being applied to the digital fingerprint of that transaction. So only those who have that private key can produce that signature. And then anyone can verify the signature just by using the public key and the transaction fingerprint. This way, the signatures of all the transactions can be verified by anyone, and the private keys remain private. So, we can use different wallets to create keys and addresses offline. If they are created correctly, they will be valid on the network without having to be approved by anyone, and then we can receive funds to those addresses and make transactions. Let's say we do some freelance work and we want to be paid in Bitcoin. We use a wallet and we create an address that we will give to the client so that they know where to pay us. We can have as many addresses as we want and receive funds at each of them, but let's say we used a single address that we gave to the client where they can send us the payment. And we made a project for a client and we received 0.0778 Bitcoin at our address, which is worth about $1,000, $1,100, $1,200, again $1,000. The value fluctuates, okay? When we asked for this amount, it was what we wanted to receive. In order for our address to receive this amount, the client for whom we worked and who now has to pay us will build this transaction in their wallet. They will write the amount for this transaction, 0.0778 Bitcoin, and the address to which to send this amount, which is the address we gave to them. Because that alphanumeric code, which represents the address, is quite difficult to write by hand, usually QR codes are used, which can be scanned by the wallet and then the address will be filled in automatically. If a single character from the receiving address is mistyped, these funds will end up at another address, and most likely it means that those funds will be lost forever. Yes? What are the chances that someone has the private keys for this address that we just mistyped? The funds will reach that address, but they will be locked there, because no one has access to them. And there are a lot of cases that have happened. Either funds sent to incorrectly typed addresses, or lost private keys. In both cases, the funds from those addresses are unrecoverable because they cannot be accessed. Okay, who needs to send us money used our correct address, their wallet billed the transaction and sent it online. Transactions sent over the network are propagated by using a technique named flooding. The nodes receive the transaction, They check it, and if it is built correctly, they will send it to the nodes adjacent to them, and so on, and in a few seconds the transaction will reach the entire network. Then our wallet, which is listening for changes on the blockchain, will inform us that one of our addresses was involved in a transaction. And it will tell us that we received 0.0778 Bitcoin with 0 confirmations. Now, let's see if you remember from the previous presentation. I'm gonna ask you, where is the transaction located at the moment? Can you guess? The answer is that the transaction is in the mempool. And from there, it's going to be selected and added in a block of transactions, which can end up being added to the blockchain. When a block of transactions, which also contains our transaction, is added to the blockchain, the transaction will have one confirmation. Any new block of transactions added over the block that contains our transaction means a new confirmation. And so on forever. There is no upper limit. The number of confirmations increases with each new block added to the blockchain. Now, we can ask ourselves, how many confirmations are enough to consider the transaction as being final? Because we know that those forks can happen, those forks in the blockchain, which will be solved after a few blocks. And we also talked about that type of attack, which is improbable, but let's say that it could invalidate, rewrite some of the latest transactions on the blockchain. The answer is that it depends on each person and the transaction they make. If we sell someone a book, 1 or 2 confirmations might be considered as being enough. Yes, I'll wait for 2 confirmations and then I'll hand them the book and I can leave. If we sell a car or an apartment, so for larger amounts, it's usually considered that after 6 confirmations, the transaction is set in stone. That's because if a fork happened, enough blocks were created so that the fork could be resolved, and quite a lot of energy was spent so that it could be considered impossible for anyone to rewrite the transactions from 5 blocks ago. And let's say we did 2 more projects and we received 0.08 and 0.07 Bitcoin. We notice that we received funds from different types of addresses. Some addresses can start with the number 1, some start with a 3, and others start with BC1. All are valid addresses. Those that start with a 1 are addresses that are now called legacy addresses. This is the initial format that the addresses had in the beginning. Those starting with a 3 are SegWit addresses, segregated witness, and those starting with BC1 are native SegWit. They have been implemented since 2017. In short, very briefly, the idea is that SegWit addresses, those that start with a 3 and those that start with BC1, among other things that they solve, they make the transactions themselves take up less space in a block of transactions, thus reducing the fees for that transaction. And we received at our address, if we add up, 23,246,93 satoshis. Yes, Bitcoin does not exist. The unit used in the code is the Satoshi. And then a wallet or a block explorer can display the value in Satoshis or Bitcoin or millibitcoin. A Satoshi is the smallest unit, and a Bitcoin is 100 million Satoshis. So we are millionaires in Satoshis. We have 23 million Satoshis. So we had all these transactions to our address, and in this way we can calculate the funds from a certain address. we look at all the transactions sent to this address and all the transactions sent from this address. Because Bitcoin has a transaction ledger. It's not like a purse in which Bitcoin are collected and from which we take out Bitcoin. But by looking at all the transactions sent to and those sent from a certain address, we can calculate the remaining funds available. One thing we need to keep in mind when it comes to having gains from cryptocurrencies is that in some countries we can pay taxes, and we have to do this for certain income amounts depending on the country. It took a bit of time for some governments to catch up with the technology, as is usually the case. So, again, depending on the country, we can have legal income from cryptocurrencies. Okay, having these funds available, let's say we want to buy a laptop. And we find a site that accepts Bitcoin, and we also find a laptop at 0.141 Bitcoin. The site told us the price of the laptop, and it will give us an address to which we can send this amount. So, we'll use our wallet to build this transaction. For a transaction to be valid, it will have to follow some rules. It must have a valid structure, yes, it must have a certain syntax. It will need to use a valid digital signature in order to transfer the amount to another address. The sum of the values from the inputs of a transaction must be greater than or equal to the sum of the values of the outputs. That is, no new amounts can be created, no extra amounts, as a result of a transaction. There was a time in the past when this was not the case. There was a bug through which a few billion Bitcoin could have been created, but it was solved. And the inputs of a transaction can be used only once. There cannot be multiple blockchain transactions that spend the same Bitcoin, so it is not possible to do double spending. So each transaction has inputs and outputs. As an output, in our case, we will have 0.141 Bitcoin to the address of the store from which we want to buy the laptop, which is exactly the required amount we want to transfer. And we need at least one input. Inputs taken from the funds we have access to. We have those 23 million satoshis because we had those transactions to our address, and we have those funds that we haven't touched yet. And they are called UTXOs, unspent transaction outputs. They are the outputs of those three transactions, outputs that we can use as inputs in future transactions which we have not yet touched, so they are still unspent. So we can use these UTXOs to have inputs for our transaction. A very important thing to understand here is that each UTXO is indivisible. When it is used as an input, it is used in its entirety. It's like when we're at the store and if we need to pay, let's say, $45 or euros, and we have a single bill, a single note of 50, we'll give them the 50 banknote in full. So, we need the transaction inputs to cover the required amount. And our wallet chose these two UTXOs. Yes, these two UTXOs out of the three we have access to, which cover the amount we need. In this example, UTXOs from a single address, our address, are used. But a wallet can use UTXOs from multiple addresses to which we have access. So we can have as inputs one or more UTXOs from a single address, or multiple UTXOs from several addresses. The wallet knows how to choose them automatically. And in this way we covered the necessary amount. This means that we will have some change that will go to an address created by our wallet. Yes, it will be an address we have access to. and usually wallets automatically create new addresses for the change. If a change address is not specified, the whole difference between the amount from the inputs and the amount sent in the outputs will end up at the address of a mining node. A situation that has happened many times. In the beginning, before we had wallets that automatically create and fill in the change address, it was necessary for the user to be careful and to realize that the transaction will have change and that they must also provide an address to receive that change. And because many people didn't know how transactions actually work and didn't know that a UTXO is actually used in its entirety as an input in a transaction, they lost the change of that UTXO. There were some who wanted to send only a small amount to another address, and because they mistakenly believed that those Bitcoin would be taken as from an account or a purse, from which you can take only as much as you want and the rest remain untouched, they ended up losing large amounts from the UTXOs used in the transaction, because they did not take into account that change. There was at least one happy case, in which a person gave about 2.5 Bitcoin as a tip, let's say, to the mining node by making this mistake. They wrote their story on the internet, and those who owned the mining operation that received those Bitcoin gave them back that amount. But modern wallets should abstract all this process, and now a simple user shouldn't worry about this. Now, if we add up the values from the inputs and those in the outputs, we see that we have a surplus value, 5,700 satoshis. Can you tell what this value represents? It represents a fee, a commission for the mining nodes as an incentive to include our transaction in a block that will go through the mining process. Because the number of transactions in a block is limited, this fee is used as an incentive to have the transaction included in a block. This fee is calculated based on the size of the transaction and not based on the amount sent in the transaction. That's why I said that SegWit addresses help with these fees, because transactions sent from a SegWit address take up less space. So, for example, a value of $50 million could be sent for a fee of only $1. How do we choose how much we want to give as a fee? This depends on how urgent we consider the transaction to be for us, and it depends on how much are others willing to give us commissions for their transactions. For example, at the end of 2017, the beginning of 2018, when there was that fast price increase and everyone was doing transactions, these fees increased. But in times when there is not so much madness going around, these fees decrease. And there are some wallets that tell us what the average fee is at the moment, and we can choose directly from the wallet how urgent our transaction is, and the wallet can also give us an estimate for the fee. And this is the transaction created in our wallet, transaction that we will send to the Bitcoin network, and it will go through all the steps and all the processes that we discussed so far. After a few confirmations, the store from which we want to buy the laptop will consider the transaction finalized and will deliver the product to us. Let's look now at how we can use a wallet and how we can create such a transaction. I'm going to show you how to set up a wallet, and I'll show you how this whole process works, and you can even follow along. Choosing a wallet might depend on whether you have an Android or iOS phone. The application I'm going to use for this demonstration that I'm doing now runs on both operating systems. And we'll need a pen and paper because we want to write some information offline. There are many wallets to choose from, each with their pros and cons. They each are good in different situations. For this particular demo, I will use Bread Wallet, but you can use any other wallet. For the most part, I chose Bread Wallet for this presentation because it runs on both Android and iOS and has a fairly modern graphical interface. There are wallets that offer us many more options that Bread Wallet has, but unfortunately they look like mobile applications from 7 years ago. Another cool thing is that it connects directly to the Bitcoin network, directly to a node randomly selected from the network. Some wallets go through an intermediate server and others connect directly to a node. It's open source and non-custodial, meaning you have control over your keys, so the keys are not held by a third party on some server. And I would recommend that you look for these pros when choosing the wallets you want to try. So I encourage you to experiment with different wallets and see which ones might best suit your needs, and for holding larger amounts to actually use a hardware wallet. The bootstrapping process for different wallets is, on a high level, kind of the same. We'll be asked if we want to create a new wallet or if we want to recover a wallet. I'll choose to create a new wallet. The app might ask us to set up a PIN. This PIN is just for this application only. It has nothing to do with the blockchain. This next part is related to our private keys and is very important. The app will generate for us a series of 12 or 24 words, which we should write down carefully on the paper. These words must be kept secret. Don't share them, because whoever has access to these words will have access to any satoshis, any funds that you are going to have in this particular wallet. So, what are these words? This idea was introduced with BIP39, which is a Bitcoin improvement proposal that was accepted and implemented, and it simplifies the way in which a user can keep track of private keys. What happens is that in fact the user no longer keeps track of the private keys. Now you just need to know your 12 or 24 words, also known as a seed, and from these words a wallet can generate an infinity of private keys, generated every time in the same order. What is important to understand here is that these keys can be recreated from any other wallet that supports BIP39, as long as we have the 12 or 24 words. So it doesn't matter if our phone or computer on which we had the wallet broke, because the funds were not in the wallet. In the wallet are the private keys that we can generate again at any time from the 12 or 24 words. These words are generated randomly by the wallet from a list of 2048 words. Words that are specially chosen to be easy to read and easy to identify just by looking at the first 4 letters. And the probability of getting the same seed as someone else is comparable to the probability of having identical private keys, meaning very, very unlikely to have the same mnemonic phrases. Next, we'll be asked to check these words to make sure we wrote them correctly. And then, we might see multiple currencies displayed in the wallet. This is because from this mnemonic phrase, keys can be created for many other blockchains, but now we are focusing on Bitcoin. And if we enter the Bitcoin section and tap on Receive, we'll have an address where we can receive funds. The address we see now might start with the number 1, and what we want to do is to go to the settings of the wallet and enable SegWit addresses. This is because valid legacy and SegWit addresses can be created from the same seed. This process of enabling SegWit addresses might vary from wallet to wallet. And now, if we go back to the Bitcoin section and tap Receive, we can use SegWit addresses, not the legacy ones. Addresses at which we can receive funds. One thing that can mislead users is that after we receive funds at this first address that is displayed, the next time we'll go to receive, the wallet will show us another address. This is a normal behavior that wallets have. They will generate a new address each time the previous one is used in a transaction. But we still have access to the previous addresses and we can still use them, as well as the newly created ones, to receive funds. I already put some satoshis in this wallet, and what I'll do now is that I will go to the send section and I will create a transaction, and I'll send some satoshis to one of my other addresses managed by another wallet. And then we'll look at this transaction by using a block explorer. One of the cons of this particular wallet is the control it offers us over fees. We have only 3 options that estimate what the confirmation time of the transaction would be. So we can't choose exactly how many satoshis per byte we want to pay. I will choose economy because I don't want to pay too much in fees, but it doesn't matter if it won't be confirmed too quickly. We can still see the transaction on a block explorer. I'll fill in the address I want to send to, and I'll enter the amount. Let's say 0.0003, which now is about $5. When it comes to sending small amounts, we can see one of the problems that Bitcoin has. Because the fees are calculated based on the transaction size and not on the value of the transaction, sending $5 could end up having a fee of, let's say, about $1. That's why second layer solutions are being implemented, like the Lightning Network, where funds can be added to a payment channel, and then those funds can be used on the Lightning Network to do really fast and secure transactions with minimal fees. Then we can close the channel and the final version of the transactions will be settled on the actual blockchain. It's similar to the way banks settle transactions. When we do a credit card transaction, for us it seems instant, but actually the banks will settle these transactions at the end of the day, or week, or even month. And because I chose a really low fee, it might take a while for this transaction to end up having a confirmation, but I'm not in a hurry. And I'll hit send. The transaction has been sent to the Bitcoin network, and I can actually see this in my wallet after it's synchronized with the node to which it's connected. So, the wallet is going to show us a lot of information about our transactions, but it's not the only way in which we can look up data on the blockchain. Let's look now at some of the information on the blockchain by using a block explorer. We can run our own node to get this information ourselves, or we can use a block explorer. There are many block explorers that we can use, like Blockcipher, Blockchair, Blockstream. Right now I'm using Blockstream. Block explorers are services through which we can actually see the data on the blockchain. For example, we can see the number of blocks mined. This is the latest mined block at the time of recording. And if we click on it, we can see the actual data from this block, like the block hash, meaning the proof of work which a mining node had to find as being smaller than the current difficulty target. There is also other information, like the number of confirmations, the size of the block, and we can see the difficulty at which this block was mined, and we see the nonce that was used to actually find a valid block hash. If we look at this information in other block explorers, we might see these values displayed differently. They are actually the same, they're just displayed in different units of measurement. We can also see the number of transactions in this block and the transactions themselves. Here we have that Coinbase transaction through which the mining node received at this address the reward of 6.25 Bitcoin plus all the fees from all the transactions in this block. And we can see that transactions can have multiple inputs or multiple outputs, like this one, where these two inputs were needed to cover this amount, and there is also a change. Let's look now at the transaction I made earlier, where I sent 30,000 satoshis between two of my addresses. The receiving address is this one, and we can see the number of available UTXOs for this address and their amount. Right now I have just one at this address, with that 0.0003 Bitcoin that I got through this transaction. If we look at the transaction itself, we can see different kinds of information, like the number of confirmations that this transaction has. For now, 0 confirmations, because the transaction is still in the mempool. We see the size of the transaction and the transaction fees. Also, this Block Explorer tells us that by using a SegWit address to send the funds, the fees were lower. And so we went through some concepts with which a simple user can interact, someone who just wants to receive, send, or hold funds. So now we have a complete overview of what a blockchain means and how we can interact with a blockchain.